So you can reflect these puppies
across either axis.
either way.
Okay, across the x-axis, what's happening when you reflect across the x-axis? You make the y's negative.
Yeah, notice y values go up. So if I reflect over the x-axis, instead of y values up, y values down.
Okay, so it just changes those signs. What it looks like in our function notation thing we've got going on here is that the negative here will be outside of your function, whatever it is.
It'll be in the very, very, very front.
So it'll be outside your absolute value bars, or outside of your parentheses, or outside of whatever. If you're reflecting across the y-axis, it makes your x's negative.
And that one is one of these sort of situations. So
depending on what you have, it may not actually, if you actually
much.
have this, that doesn't really change anything. But depending on what it is, it could really affect things.
But
most
again,
of the
it's
time,
only x values that change.
Yeah, most of the time you will end up with a reflection across the x-axis. That one is so much more common than the reflection across the y-axis. I'm not entirely sure why, but I'm telling you it is. So if you had to guess x-axis. Yeah. But don't guess, just know it. All right, so
always know.
Example 2 says find an equation of the reflection of f of x equals 5x minus 9 over x squared plus 3 across each axis.
That looks really hard.
That's a pretty crazy function. That's not a parent function.
Do we have to do long division on this?
No, all we're going to do is use our rule here.
Okay, if you say so.
If we are reflecting across the x-axis, let's do that first. What do we have to do? Whoops.
Whoa.
X-axis. What do we have to do? We have to make our y's negative. In other words, make your function negative.
So, okay, let me guess. Negative 5x minus 9 over x squared plus 3.
That is correct. So f of x, our new f of x, will become a negative in front, 5x minus 9 over x squared plus 3.
Is it really just that easy?
It is just that easy, because what's going on is this whole thing was f of x.
Right.
It wasn't some parent function hidden inside that we were trying to deal with. They told us what f of x was, which means we need to put the negative outside of our function. Outside of our function is bam, out in front.
Okay. I like it.
It's not on the top or the bottom, it's just out in front.
So there's no trickeration here.
No. Now, y-axis.
Okay.
We want to make our x's negative.
All right. Now this is going to be, pay attention, because now there could potentially be some math involved.
Right.
Okay?
So our new function, if we make all of our x's negative, that means where we have x.
You put negative x in.
Right. And I'm going from the original here, not from what we just did to get the x-axis.
From the original function. Everywhere you see x, put negative x in.
An issue. You have to put negatives in parentheses.
If you don't, you're going to have, those will be points you'll miss when you shouldn't have. You'll get whatever was graded back, and you'll be like, oh.
Silly mistake. Okay, so 5 times a negative x is?
Negative 5x minus 9. That's your topsies.
That is. Now, negative x squared.
That's negative x times negative x.
Which is positive x squared.
Righto.
So on top our negative didn't go away, but on the bottom it did.
Now,
so this is our.
That's a reflection over y.
Yes.
And notice, we didn't go through and just change all the pluses and minuses around.
That's right.
We did some math on this.
You have to do the x's only. We didn't change all the signs. We actually only changed one sign on the whole thing.
Right.
And it just somehow makes that flip.
Right.
Go figure.
That's what you have to do.
Yeah.